Hello everyone. My name is Kunal and I'm your physics tutor. And we're actually doing ray optics. And today is our lecture number 7. So let me quickly recap the things कि हमने previous classes में क्या क्या चीजें cover करी थी. So हमने previous classes में सबसे पहले कुछ formulas को prove करे थे. यहाँ पे हमने कुछ फॉर्मूले देखे थे which is F focal length is equal to हमने R/2 प्रूव करा था for पैराक्सियल रे, राइट. जब भी हम लोग कोई भी फॉर्मूले डिराइव कर रहे होंगे वी आर एक्चुअली डिराइव फॉर द पैराक्सियल रे, राइट. दैट मीन्स आफ्टर रिफ्लेक्शन रे ऑफ लाइट आर passes through the actually passes near to, basically passes near to the pole. Okay, so we are actually derived for the paraxial ray, or for marginal ray we are something look like this f r1 minus 1 by 2 cos theta. This is the actually focal length for the marginal rays, right. फिर हमने साइन कन्वेंशन देखी थी जो कि बहुत इंपॉर्टेंट था, जिसमें मेन लाइन जो था ये था कि you have to take positive in direction of incident light and rest of the things will be taken as negative. जो थर्ड फॉर्मूला हमने डिराइव करा था वो थी मिरर फॉर्मूला which is actually termed as like 1 by u. यहाँ पे हमने कुछ टर्म्स भी देखे थे like u denotes the object distance from pole, v denotes the image distance from pole, and it is actually equal to 2 by r or it is actually equal to 1 by f. इसको हमने मिरर फॉर्मूला नाम दिया था and we can also call it like v is equal to uf by u minus f, and you have to very carefully use the sign convention and all. So ये सारी चीजें हमने डिस्कस करी थी, right. In today's class we are going to discuss about the ray diagram first, right. So let me give the headings. Actually ray diagram. Okay, so there was some concept, so you have to keep those things in mind. So let's start. First we are talking about let me give the heading for the concave mirror. Similarly we are also talking about the convex mirror as well, but first we are going to talk about the concave mirror. So let's start. The first, whenever like suppose this is actually our concave mirror, and suppose the ray of light is actually incident parallel to the principal axis, the after reflection it passes through the principal axis and the point is actually known as focus. Okay, this is the first thing that you have to keep in mind. Second, let me draw it here. Let us suppose this is actually a concave mirror and there is pole. Okay, this is actually our principal axis. So whenever a ray of light is actually incident on pole, so after reflection, it actually makes the same angle like theta, so it reflected through the angle theta, right? This is the thing. Third concept, if a ray of light is actually passes through center of curvature, so okay, let me draw it in a good way. So whenever a ray of light is actually pass through the center of curvature, so it rebound. Fourth point is actually whenever a ray of light is incident from focus, like it passes from focus, so after reflection it actually goes parallel to the principal axis. So these things that you have to keep in mind for concave mirror. So let me tell you again, जब भी कोई इंसिडेंट रे ऑफ लाइट प्रिंसिपल एक्सिस के पैरेलल इंसिडेंट होती है कॉन्केव मिरर पे, सो आफ्टर रिफ्लेक्शन वो एक प्रिंसिपल एक्सिस को एक पॉइंट पे कट कर रही होगी, उस पॉइंट को कहते हैं फोकस. नेक्स्ट, अगर कोई इंसिडेंट रे ऑफ लाइट पोल पे सीधा इंटरेक्ट करती है, सो आफ्टर रिफ्लेक्शन इट बेंड टुवर्ड द सेम एंगल, राइट. द थर्ड थिंग, इफ अ रे ऑफ लाइट इट पासेस थ्रू center of light, if an incident ray of light passes through center of light, then it's basically redirected to its path. ठीक है, वापस उसी path पे आ जाएगा. Fourth point, if a incident ray of light is passing through the focus, so after reflection the reflected ray is actually parallel to the principal axis. Okay, so these things that you have to keep in mind. So this is actually our the reflected ray, this is actually our incident ray, reflected ray. In this, incident and reflected ray are on the same line, and in this is actually our focus when a ray of light when an incident ray of light is passes through the focus, so after reflection, reflected ray is parallel to the principal axis. So this is actually our principal axis. Okay, so I hope this will be clear to all of you, right? Now, what I'm gonna tell you now, the next thing we have to deal about the convex mirror, right? So let's start. So for the convex mirror, let me give the heading here, convex mirror. So this is actually our, let us suppose, convex mirror. Okay, and this is actually our principal axis. Okay, so whenever a ray of light is actually incident parallel to the principal axis, so after reflection, right, it's like appear to meet at a point, right? In case of that, this is actually focus. The concept is same. Whenever a ray of light is incident parallel to the principal axis, then after reflection, it passes through focus. Either it passes through focus or appear to passes through focus. In this, in the concave mirror case, it is actually passing through focus. But in the case of convex mirrors, it appeared to pass through the convex. It's appeared to pass through the principal axis, right? So that's what I'm trying to say. Whenever a ray of light, whenever an incident ray of light is parallel to the principal axis, incident parallel to the principal axis, so after reflection, it passes after reflection, either it pass through the principal axis or appear to pass through the principal axis, right? So in the case of concave mirror, it passes through the principal axis, and in case of the convex mirror, it appeared to pass, right? It appeared to pass through the principal axis. So this was actually this is the thing that you have to keep in mind. Now the next thing, this is actually the first one, and same as the concave mirror, the second part. Let us suppose this is actually our convex mirror, and this is actually our pole, and the ray of light is actually incident on pole. So after reflection, it actually passed through the same angle, which is actually theta. The third one, which is actually, let us suppose this is actually our convex mirror, and there is its center of curvature. So if a ray of light is incident and it appear to pass through the center of curvature, so after reflection, it's again appear to reflected as or the redirected through the same path. Okay, so this is the thing that you have to keep in mind. The fourth one, again, let us suppose this is actually our convex mirror, and if a ray of light is actually incident through focus, so after reflection, it goes parallel to the principal axis. This is actually incident light. After reflection, it goes parallel to the principal axis. Actually, let us suppose this is actually our incident ray of light. This is actually appeared to pass through the focus. So after reflection, the ray of light, after reflection, the ray of light actually passing through the principal axis, right? So these are the things that you have to keep in mind, right? Convex mirror, concave mirror. ये सारी जो है ना रे डायग्राम है. So यहाँ पे आपको एक चीज मैं बताता हूँ, एक नोटेड पॉइंट है, which I'm gonna write it here. Use any two ray for ray diagram. Whenever you have your question asks to form the ray diagram, use only two ray. In the case of when the ray of light is actually passing through the center of curvature, so it's actually redirected through the same path, right? It redirected through the same path, but usually what you have to do whenever you have to ask for to draw the ray diagram, so you have to use any two ray, right? Whatever the core of the ray I'm given here, you have to use any two ray to draw the ray diagram of the NAP, right? So you have to remember two or three things whenever the ray of light is actually, whenever the incident ray of light is actually parallel to the principal axis. So after reflection, it passes through the focus. Second things, whenever the ray of light is actually incident on the pole, after reflection, it like a perfect reflection, right? And whenever a ray of light is actually passing through the center of curvature, so it redirected to the same path. Fourth, whenever a ray of light is passing through focus, so after reflection, the reflected ray is parallel to the principal axis. It is actually applied to the concave mirror. In case of convex mirror, whenever a ray of light is actually incident parallel to the principal axis. So in case of convex mirror, it's appeared to pass through a principal axis, which is, and the point it's passed or it appeared to pass is actually known as focus. And the same for the pole. And the third one is also same for the center of curvature of the case. And again, in the case of focus, whenever a ray of light, whenever an incident ray of light is actually passing through focus, so after reflection, actually the reflected ray is actually parallel to the principal axis. So these are the things that you have to keep in mind, right? And so now on, we are going to discuss about the magnification of the magnification due to spherical coordinates. So these are the things that we are going to discuss. And okay, so let's start. Our new topic is magnifications due to spherical. This is actually represented by small m. Okay, so this is actually represented by the small m. So there are actually two kinds of magnifications. So let me define the first one. Okay, so these are actually kind of formulas, so you have to just keep in mind. The first is actually transverse magnifications. So the transverse magnification, these are actually terms, so you have to just keep the formula in mind. So what is actually transverse magnifications? So the transverse magnification is actually equal to the like y coordinate of image and divided by y coordinate of object. Or you can say this is same as height of image by height of object. So this is actually our and I'm again saying you have to use the sign convention in a good manner. Okay, you have to use the sign convention in a good manner because this is the thing that will help you. Okay, so you have to like use and you have to use the sign convention in a well manner. Otherwise, it will be actually you get the wrong answer. So that's what I'm trying to say. Okay, so HI by HO, right? And or what else we can say from here is our M is actually is equal to HI by HO and it is actually equal to minus V by U. Okay, so now the question is how can we say like it is minus V by U, right? So okay, I'm actually claim that the transverse magnification in a mirror, in a spherical mirror is actually height of image by height of object. This is actually defined, but I also define it is actually equal to minus V by U, where you all guys are actually familiar with what is V and what is U. V is the distance of the image from pole and U is the distance of the object from the pole, right? So these are the things that we define. And it is also equal to, like, I'm going to tell you, like F by F minus U. Now it's a very confusing things. And you want to ask why you write those terms as like HI by H minus V by U and F by F minus U. So right now I'm just claiming that this is actually equal. So now let's prove it. है ना? So proof देखते हैं. हमें prove क्या करनी है? We have to prove. Let me write it here. We have to prove like M is equal to, is actually defined HI by HO, height of image by height of object, which is actually equal to minus V by U, and it is equal to F by F minus U. Okay, so let's do. So I'm doing it for concave mirror. It is actually similar for the convex mirror as well. So I'm taking it as for concave mirror. So let us assume this is actually our pole, and this is actually our O dash is our height of object, है and whenever we have to draw its image, we have to use two rays, as I earlier told you. Use any two rays for the ray diagram. And actually, I'm drawing the ray diagram, so I have to use only two rays. So first, I'm trying to use like I'm using the ray which is actually uh, parallel to the incident ray is actually parallel to the principal axis. So after reflection, we know it passes through the focus. So it actually passes through the focus. The second ray we are using, it's actually passing through the pole. So let me use the ray which is actually passing through the pole. So after reflection, Okay, so this is actually theta. This is obviously theta. So there is actually our, you can say I dash. Anna, you can say I dash. If I zoom in here, so you can look very carefully. I use two ray of light. One is actually, this is actually our first ray of light, and this is actually our second ray. This is first, this is second. The first incident light is actually parallel to the principal axis, so after reflection it passes to the focus. And the second incident light is actually directly passing through the pole, so after reflection it also passes into the pole. And there is our actually I. Now this is actually our theta, and this is also our theta. If I zoom in, so it will be clear to you. This angle is actually theta, and this angle is also theta, right? And what I'm gonna use, I'm actually using theta as, let me show you. I'm using this as theta, right? So okay, now here from here, the okay from here, like we can say tan theta is actually is equal to what we can say in this triangle, in actually above triangle. So P by B, O dash by U, right? Like as we know, tan theta is actually perpendicular by base. So the perpendicular is this one, and base is this one for the above triangle. And it is actually same as for the lower triangle, because the above and the below angle is obviously theta. So it's actually equal to I dash, which is actually with the negative sign, but I'm not going to take it right now. And it is actually equal to B. I'm not using the sign convention right now. Okay. So whenever I use the sign convention, it will be clear to all of you now. So we are actually defining as M is equal to actually HI by HO. So if I, from this equation, we get O dash, or you can say I dash by O dash, just cross multiply it. So we will get V by U, right? So HI by HO is equal to, here we get YI by YO, which is actually is equal to V by U. So when we use the sign convention, so look at here. Our sign convention says this is actually above the x-axis. So it is actually HI is negative. So we can say minus HI, and object is, or height is positive because it's above the x-axis. Now our U and V both are negative because both are it's in the inverse direction from the incident ray of light, because our incident ray of light is actually going in rightward direction, but from pole our object and image formed in the leftward direction. So what I'm going to take it here is minus V by minus U. So both get cancelled. What we get? HI by HO is equal to minus V by U. As I earlier told you, as I earlier claimed that at a height of that the transverse magnification is actually is equal to height of image by height of object, and it is actually equal to minus or the negative times of velocity. What I'm trying to say. Okay, V, I'm gonna tell you the final velocity. Sorry, my bad. The V is actually the distance of image from the pole, and U is actually the distance of object from the pole. Right. So I'm again gonna tell you, use the sign convention in a very good manner because it's very helpful to all of you. Right. Otherwise, you get the sign issues. So I'm gonna write it here, and I have to prove one more thing, right? But first thing I'm gonna tell you here is use sign convention carefully, because this is the thing that you have to learn in the optics. Because if you change the sign like plus to minus, it's a big blunder. Okay, you get the very diverse answer, basically answer, which is actually not correct. So use the sign convention carefully. Now we have to one more thing that we have to prove, which is actually minus v by u is equal to f by f minus u, and this is actually easy, right? So how can we prove this? The first thing we prove, like hi by h is equal to minus v by u. Now the second thing, let me write the proof of 2b, actually proof of b. So I'm going to prove it. So we have a formula like v is equal to uf by u minus f. And what is it? It is actually mirror formula, which we derived in our previous lecture. So this is actually mirror formula. V is equal to uf by u minus f. So we all know that from, let me call that equation number 1. So from equation 1, we know hi by ho is equal to minus v by u is equal to, so it will be like minus of uf by u minus, right? Oh, sorry. So from here, like we can write v by u as f by f minus u, right? U minus f. Okay. Wait. I thought I just doing has here. Okay. Okay. So let me write here. So this is actually our mirror formula, right? This is actually our mirror formula. And look at here. Here we can write v by u as f by u minus f. From this equation, right? We can write now u minus f. Now we have to u minus f. Now here we have like minus v by u. So when we multiply from both sides with the minus sign, so what we can do? There is actually, okay, u minus f. So when you multiply both sides with the negative signs, and I think there is no more u because we already multiply uh, by 1 by u in v, right? So there is no more. Okay, so now there is no more u because it's already multiplied in the denominator of v. So when you do so, what we get? F by f minus u we can write now. I just take the negative sign common from the denominator. So it is actually equal to, I hope it will be clear to all of you, right? Like f by f minus u. This is the thing that we are going to prove. So here we actually prove. So I just use the mirror formula here, right? The mirror formula is like v is equal to u by u minus f. And I just take it is the minus v by u. It is actually equal to minus f by u minus f, right? So I hope this will be clear to all of you. Now let's uh, analyze something which is actually important. So let me write its analysis. So what is actually the significance of M, right? So we are analyze about the significance of magnifications. Okay, so the first thing is, what if our M is greater than 0 and M is greater than 1? That means you can say M is positive. What if our M is positive? So if M is positive, that means image is erect and larger. That means you can say height of image is greater than height of object, right? The image is erect image. Erect image, like that means it's not basically like ऐसा समझ सकते हो. If this is actually our object, so the image will be like this. Same erect image, right? So this is the significance when the M is positive. The image formed is actually erect and the larger. That means height of image is actually greater than height of. Now let's move to the second things, which is actually I'm going to tell you what if our M is less than 0 and M is less than 1, right? What I'm trying to say, in this case, actually M is our negative and M is also less than 1. Either the M is less than 1, you can say, or the M is negative. So in this case, actually image is again erect and smaller. I'm just talking about the concave mirror. Mark my word. I'm not going to talk about the convex mirror. Maybe the things were different in that case. But I'm just talking about the concave mirror, right? I'm not talking about the convex mirror right now because, again, I'm trying to say you. Maybe the things were different in that case. So we will discuss the convex mirror also. But first we are discuss about the concave mirror. So in this case, image is erect and smaller. That means you can say height of image is actually less than height of object. The third thing and the third case, what if our M is exactly equal to 1? So in this case, the image is of same size with respect to object. What I'm going to tell you is, I'm telling you is like in this case, when the M is exactly equal to the 1, so in this case, image is of same size with respect to the object. So let me tell you again the significance about the significance of M. So basically we are analyzing the things like what if our M is positive, M is negative, and M is equal to 1. So if the m is positive, the things you have to remember, like image जो बनेगी वो erect image बनेगी, and height of image will be greater than height of object. The next thing you have to keep in mind, अगर m negative होगी या एक से छोटा होगी, in that case, जो image बन रही होंगी वो erect ही बनेगा but smaller in size. The third things, if m is actually is equal to 1, then in that case, image is of same size with respect to the object. Right. So I hope this thing will be clear to all of you. Now, let's move on to the next topic, which is actually, I'm earlier told you, we have actually two types of magnification. The first is actually transverse magnification, and the second one is actually longitudinal magnification. So let me write it here. Longitudinal magnification. It is actually represented by ML. Okay, so how it is defined as? So the longitudinal magnification is defined as length of image. Actually, it is termed to the height of image, right? Like height of image by height of object. And it is actually defined as the length of image by length of object. Or you can say Li by Lo. Okay. Now, for large object, like whenever we consider for the large object, so let me take here some cases. Case one, like if I'm considering for the large object, right? Obviously I'm with respect to the I mean the distance of object from the pole. So I'm talking about the large object. So what happened in that case? In that case, we have actually longitudinal magnification is actually is equal to delta V by delta U. This is actually our, and I'm going to prove it because I'm just claiming that ki ye hoti hai. How I'm going to prove it? Just watch it. So look at it. Let us suppose this is actually concave mirror. You can also do it for convex as well, right? So it's not the big deal. You can also deal it with the convex mirror. Okay, so look at it. So this is actually my convex mirror. And let us suppose this is actually our big object, right? So whenever the image is it's actually formed. So find the image of the A and B. What you can do, find the image of the A and B and using the mirror formula and get the delta V. This is actually our delta U, right? And how you calculate the delta V? So calculate delta V by using by finding the images of A and B using mirror formula. That means what I'm trying to say, अगर आपके पास बहुत बड़ी ऑब्जेक्ट हो, सो आपको क्या करना है, उसके एंड पॉइंट को ए एंड बी नाम दे देना है, उस लेंथ का बेसिकली ए का आपने मिरर इमेज फाइंड करनी है, बी का मिरर इमेज फाइंड करना है, ये वो आपको डेल्टा वी दे देगा. ठीक है, आपको लाइक यहाँ पे डेल्टा यू डेल्टा वी कैसे लाइक एक्चुअली जो थिंग्स है, लाइक डेल्टा यू तो हमें पता चल गया कि एक एंड कहाँ पे है. देखो सबसे पहले क्या करना कि अगर ऑब्जेक्ट बड़ा रहे तो आप उसको कैसे उसकी लॉन्गिट्यूडनल मैग्निफिकेशन निकाल सकते हो. तो एक एंड को एक नाम दे देना और दूसरे एंड को दूसरा नाम दे देना. अब आपने करनी क्या है कि दोनों एंड पॉइंट की मिरर इमेज लेनी है. पूरी ऑब्जेक्ट की मैं मिरर इमेज नहीं निकाल रहा हूँ, मैं बस क्या कर रहा हूँ कि लाइक ऑब्जेक्ट मेरा ए से बी के बीच में है, तो मैंने ए का मिरर इमेज ले लिया, बी का मिरर इमेज ले लिया. अब जो इमेजेस आएंगी वो ए और बी, जैसे मान लो कि ए का इमेज आया ए डैश, बी का इमेज आया बी डैश, तो जो रेस्ट ऑफ द ऑब्जेक्ट है वो तो ए डैश एंड बी डैश इमेज के बीच में ही होगी ना, है ना. सो व्हाट आई एम गोना टेल यू इज, जो ए डैश एंड बी डैश के बीच के जो डिस्टेंस है, राइट इट एज डेल्टा वी. उसको आपने क्या करना है, डेल्टा वी के नाम से रखना है कि वो है मान लो मेरा डेल्टा वी, है ना. ए डैश एंड बी डैश के बीच के जो डिस्टेंस है, व्हाट आई एम गोना टेल यू इज दैट वन इज माय डेल्टा वी डैश. And then you are able to calculate the for the larger object. Now we are considering the case 2. So in case 2, what I'm gonna write it here is, okay, for case 2, for object is very, very small with respect to u. Okay. In the first case, I'm assuming that the object is very, very large. And in the second case, we are assuming that the object is very, very small. Okay. So from here, what like we derive here, like ML is equal to delta V by delta U. So what here we can write? Here we can write as ML is equal to dP by du, because our object is very, very small, right? So let's try to find it out. Okay, what is actually dV by du? So we have a mirror formula. So from mirror formula, right? So from mirror formula, what we have? We have 1 by V is equal to, actually 1 by V plus 1 by U is equal to 1 by F. So this is actually our mirror formula, right? Now what I'm going to do it here is I'm just differentiate both side with respect to U. I hope you all know like how to differentiate, like, right? So when I differentiate like actually 1 by V, so it will be get 1 by V square dV by du minus 1 by U square du by df. Actually du by, so it will be actually 1, right? Let me erase it from here, because u is actually differentiating with respect to u, so it will be gives you 1. And 1 by f is actually constant here because focal length and the length is constant, so it will be actually 0. Let me write it here. 1 by f is constant now because it's a focal length. It's a length, so it will be 0. So here we will get dv by du is actually is equal to what we'll get? We'll get minus v square by u square, right? Minus v square by u square. So here we can say our ML, that means longitudinal magnification, is actually nothing but minus of v square by u square. Now there is a quick turn here. As we know that, we have a transverse magnification, which is actually equal to minus of v by u. So here we have a relation. There is a relation. There is a relation between ML and M. And what is it? It is actually nothing but ML is equal to minus of M square. That means longitudinal magnification is actually is equal to negative of transverse magnification square. And you have to keep one thing in mind, that is like noted point. You can say here the negative sign actually represent, or you can say so, always inversion, right? So let me quickly recap once कि मैंने यहाँ पे क्या-क्या चीजें आपको बताया. So like we have actually discussed the magnification thing. So यहाँ पे दो तरीके का magnification होता था, मैंने बताया आपको. The first is like transverse magnification and the second is actually longitudinal magnifications, right? So in transverse magnification, what we have a formula like magnification is equal to hi by ho, which is actually height of image by height of object. And I'm actually first claiming that it is actually equal to minus v by u, and it is actually equal to f by f minus u, right? Then the next thing we are going to prove it via using the simple like trigonometric ratios, where actually I'm using the tan of theta, and the tan of theta will be like p by v. So I'm going to use it as o dash, which is actually the height of object. And you can similarly watch the proof. It will be easy, right? And then I use the mirror formula. Then I include the mirror formula in it, and then I get the minus b by u as f by u minus f. And when I implement here, I get the hi by h is equal to minus v by u, is actually equal to f by f minus u. It is actually easy, right? Like how to prove. You have to just keep one thing in mind. And the things is, you have to very careful about the sign convention, right? Because the sign convention is the only things where you can do mistake in this chapter. Otherwise, concept is very easy. You have to always, you have to always be careful about the sign convention. Okay, so because गलत होने की चांसेस वहीं पे ज्यादा होती है. देन एक्चुअली वी डिस्कस अबाउट द साइन कैन द सिग्निफिकेंस ऑफ द एम. व्हाट इज एक्चुअली द सिग्निफिकेंस ऑफ ट्रांसवर्स मैग्निफिकेशन. सो यहाँ पे हमने डिस्कस ये करी कि अगर एम की वैल्यू पॉजिटिव रही होगी देन उसका मतलब ये होता है कि इमेज जो है वो इरेक्ट बनेगा एंड इमेज विल बी द लार्जर देन द हाइट ऑफ इमेज विल बी द लार्जर देन द हाइट ऑफ ऑब्जेक्ट. If the m is negative, then the image is actually smaller than the object and the image will be erect. This is actually we are discussing about the concave mirror. Actually we are also discussing about the convex mirror, so don't worry about it. Let us see whether the things we are discussing here is similar or different, right? Like whether I'm trying to say is whether in the case of convex mirror, if m is negative or m is negative, then is the image is erect or the smaller than the object or else thing happening, right? So we are gonna verify that. If I'm claiming something, I will definitely prove it. The third things we discuss, if the m is actually is equal to 1, if his m is exactly is equal to 1, so the image height and the object height is actually same. It is actually is equal to 1. The next thing is about the longitudinal magnification. So in the longitudinal magnification, it is actually defined as the length of image by length of object. As the transverse magnification is defined as the length of object, actually the height of image by height of object. So in this case, we are taking the two cases. In first cases, what if our object is very very large. So if the object is very very large, so आपने बस दो कामें करनी है. The first thing you have to do is ये दोनों एंड पॉइंट को, स्टार्टिंग एंड एंड पॉइंट को आपने क्या करना है, ए एंड बी मार्क कर लेनी है. अब मैं क्या बोल रहा हूँ कि ए एंड बी पॉइंट की आपने इमेज फाइंड करो. ठीक है, मैंने ए एंड बी की इमेज जैसे ही फाइंड करा, मुझे पता चल गया कि ए, लेट अस सपोज ए डैश एंड बी डैश इज द इमेज ऑफ द ए एंड बी. तो ए डैश एंड बी डैश के बीच में ही तो जो रेस्ट ऑफ द ऑब्जेक्ट है उसकी इमेज बन रही होंगी. दैट व्हाट आई एम ट्राइंग टू से कि ये ए, मान लो यहाँ पे बन रहा है ए डैश, यहाँ पे बन रहा है बी डैश. तो जो रेस्ट ऑफ द ऑब्जेक्ट है वो इसके बीच में ही तो है ना, मतलब इसके बीच के जितने भी पॉइंट्स हैं उसकी इमेज यहीं पे तो बन रही है ना. So that what I'm trying to say. The rest of the, just find the images of the extreme point. When you find the images of the extreme point, you automatically get the image between them. So you are able to calculate the delta V by using the mirror formula, right? The next case I'm discuss is what if our object is very very small. So we are familiar with the the longitudinal magnification, which is actually is equal to length of image by length of object. So it is actually is equal to dv by du, right? We already derive it in the above. So from the mirror formula, we have to calculate like what is actually dv by du. So we have a mirror formula which is actually 1 by u plus 1 by v is equal to 1 by f, where 1 by f is a constant because it's a distance, it's a focal length, and the focal length represented distance. So what I'm doing here is I'm just differentiating the mirror formula, with respect to u. So when I differentiate, what I get like minus 1 by v square dv by du. V as a function of u I'm differentiating, then minus 1 by u square, because we all know that the differentiation of 1 by x is actually minus 1 by x square. So using that concept, I'm just differentiating it. So what I get dv by du is equal to minus v square by u square. And when I saw the term minus v square by u square, I immediately recall to the like something, v by u is our actually transverse magnification kind of thing. So we got a relation also. We got here two things. First thing we got is the longitudinal magnification formula. And the second thing, we got a relation between longitudinal magnification and the transverse magnifications. And the relation is actually, longitudinal magnification is actually equal to negative of square of transverse magnifications, right? So these are the things. And then here the negative sign just represent the things is like always inverse kind of thing. This is only representing, right? So I hope you learn lots of things and lots of the concept from the today's class. So that's all for today's. In tomorrow's class, we are going to discuss about the velocity of the objects and the image. Velocity of objects and images, जिसमें एज जैसे हमने प्लेन मिरर में किया था, जैसे वहां पे हमने डिराइव करी थी कि प्लेन मिरर में क्या होता है, वेन एवर द parallel and perpendicular, right? So whenever the object is actually traveling the parallel to the mirror, so it will be like same. But whenever it's travel perpendicular to the mirror, so it will be in inverse direction. So हमने क्या किया था, velocity हम वहाँ पे कुछ रिलेशन निकाला था कि velocity of image with respect to mirror is actually equal to velocity of object with respect to mirror. Velocity of image with respect to mirror is actually is equal to velocity of object with respect to mirror in case of parallel. But in case of perpendicular, we have some different relation. Actually, we derive it there, right? So the same thing we are going to discuss for the spherical mirror, because these are the relation is only valid till plane mirror. So in tomorrow's class, we are going to discuss about the velocity of objects and mirror. And then we are going to discuss about the things like some table of images ki kahan pe object रखने से kahan pe images बन रही होंगी. So these are the things that we are going to discuss in our next class. Okay. So that's all for today's. Okay. Thank you. I hope you all learn lots of things in today's class, right? So, okay. Thank you.